Day 534 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1625, lexicographically smallest string after applying operations. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go on and check out that link in the description so you can get you some. Now let's see what the question says. You are given a string S of even length consisting of digits from 0 to 9 and two integers A and B. You can apply either of the following two operations any number of times and in any order on S. Add A to all odd indices of S, 0 index, digits post 9 are cycled back to 0. For example, if S equals the string 3, 4, 5, 6 and A equals 5, S becomes 3, 9, 5, 1. Rotate S to the right by B positions. For example, if S equals the string 3, 4, 5, 6 and B equals 1, then S becomes 6, 3, 4, 5. Return the lexicographically smallest string you can obtain by applying the above operations any number of times on S. A string A is lexicographically smaller than a string B of the same length if the first position where A and B differ, string A has a letter that appears earlier in the alphabet than the corresponding letter in B. For example, the string 0158 is lexicographically smaller than 0190 because the first position they differ is the third letter and 5 comes before 9. All right, y'all, so I can understand how that may be difficult to understand. So let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input S equals a string 5525, A equals 9, B equals 2. The output is a string 2050. Explanation, we can apply the following operations. So to start, we start with 5525. So then after that, we're going to rotate because B equals 2. So we are going to rotate 2. And now after we rotate 2, we have 2555. Then we are going to add. So we're going to add 9 to, it says right here, we add A to all odd indices of S. So we are going to add 9 to all indices of all odd indices of this. So since 9, this is index 1 and this is index 3, which makes them the odd indices. When we add 9 to this 5, we get 14, but it says right here, digits post 9 are cycled back to 0. So what that means is since it's 14, we're just going to worry about the 4. So after we add 9 to this 5, instead of putting 14, we just take the 4 from that 14 and put this 4. And similarly with this 5, after adding 9 to that 5, we get 14. But once again, we just are worried about the 4. So now the string becomes 2454. Then we add again. So this time, same thing, we're adding on the odd indices. So we add 9 to this indice, or this index, and we add 9 to this index. So 9 plus 4 is 13, and once again, we just worried about the 3, so that 4 becomes 3, and same thing with this 4, it becomes 3, and we're left with 2, 3, 5, 3. Then we are going to rotate. So when we rotate, once again, we're rotating by 2 because B equals 2, and it says rotate S to the right by B positions, and in this case, B is 2. So when we rotate by 2, the string becomes 5323 because we take these 2 and we just rotate them. This 3 will come, that'd be one rotation. Then this 5 will come, and that's the second rotation. Then we do add again, only on the odd indices. So that's this 3 and this 3. So we add 9 to 3, that becomes 12. We're only worried about the 2. So this 3 becomes 2. Same thing with this 3. We add 9, it comes 12. And we're only worried about the 2, so we put the 2. Then we add again right here. So once again, 9 plus 2 is 11. We only want that 1, so we put the 1. Same thing right here. We only want that 1, so we put the 1. Then we rotate again. When we rotate again, B equals 2. So we take these two, we rotate them, boom, now it's 2, 1, 5, 1. Then we add again. 1 plus 9 is 10, so we get that 0. Same thing, 1 plus 9 is 10, so we get that 0. And we're left with the string 2050. And then it says there is no way to obtain a string that is lexicographically smaller than 2050. So that's why our output is 2050. So just in case that didn't make sense to y'all, let's take a look at example 2. In example 2, we have our input S equals 74, A equals 5, B equals 1. The output is 24. Explanation says we can apply the following operations. So we're going to start with 74 because S is equal to 24. Then we're going to rotate. So when we rotate, once again, we rotate with by B, which in this case is 1. So we just take this 4, rotate it once, and now it becomes 4, 7. Then we're going to add. So when we add, it's only on the odd indices. So we're looking at the 7. 7 plus A or 5 is 12. We only want the 2. So now the string is 42. Then we rotate again. So we move this 2, 1. We rotate by 1. So we move this 2, or we rotate this 2 one time, and now it becomes 24. And then it says there's no way to obtain a string that is lexicographically smaller than 24. Then finally, but certainly not least, we have example 3, where the input is a string 0011. A is equal to 4, B is equal to 2. The output is 00011. Explanation says there are no sequence of operations that will give us a lexicographically smaller string than 0011. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. So the first thing we're going to do is we're going to initialize the result with the original string. So we're just going to declare a variable called, we're going to declare a variable, call it S, we're going to call it res, and we're going to set that equal to S. Boom. Then we're going to use a queue for our breadth first search, and it stores all the strings to explore next. So we're going to say var q colon dq, then we're going to say less than string greater than equals an array S. Boom. Then we're going to keep track of visited strings to avoid revisiting the same string. By coming underneath that, we're going to declare a variable called visited, and we're going to say colon, that's going to be a set. We're going to say less than string greater than, and we're going to set that equal to an array of S, or a set of S, I should say. Boom. Then we're going to, first we need to create our helper functions. One helper function is going to be for the add operation. So it's going to add A to every digit at the odd index, and each addition is done modulo 10. So we're going to come right here. We're going to declare func, say add, open up the parentheses, underscore S, colon, that's going to be a string. Boom. Then we're going to say comma, underscore A, colon, that's going to be an integer. Come outside these parentheses, it's going to return a string. Then we can open up the brackets. So first we need to convert each character into an integer by saying var nums. We're going to set that equal to an array. Open up the parentheses S. Come outside those parentheses and say dot map. Open up the brackets, and we're going to say int. Open up the parentheses. We're going to say string. Open up the parentheses again, and we're going to say $0. Boom. Then, y'all, hold on. Let me make sure that this is right. It should be, let me see, y'all. So I need to close these parentheses, and I need to put an exclamation point right there to force unwrap it. And then we're going to come right here, and we need to apply the addition to the odd indices only. So we're going to say for I in 0 dot less than nums dot count. We're going to open up the brackets, and we're going to say if I mod 2 does not equal 0. That's how we're going to get the odd indices. We're going to open up the brackets and we're going to say nums square bracket I is equal to nums, we're going to open up the parentheses and say nums square bracket I, come outside the square bracket and say plus A, come outside those parentheses, and we are going to say mod 10. Boom. Then we're going to convert back to a string and return by coming right here, and we're going to say return strings dot map, open up the brackets, and we're going to say character, open up the parentheses, string, open up some more parentheses, say $0, and then, sorry, I need to close these parentheses as well. Boom, hold on. Make sure, so we got this, this, and this. Oh, sorry, this should be, sorry, y'all, it was supposed to be strings, open up the parentheses, nums dot map, and then boom, close the parentheses, boom. Then we need another helper function to rotate the operation, and this is going to move the last B characters of the string to the front, so we can come outside of this function, and we are going to create another func, call it rotate. We're going to open up the brackets, we're going to say underscore s colon equals a string then we're going to say comma underscore b colon, that's going to be an integer, come outside the parentheses, and it's going to return a string. Boom. Then we're going to open up the brackets and we're going to say string, open up some parentheses, s dot suffix, open up some more parentheses, pass in b, come outside those parentheses, still inside the other parentheses, and we're going to say plus s dot prefix, open up some more parentheses, and we're going to say s dot count minus b. Boom. And then we need to and then that's it for that helper function. Now we need to get back up here, or that's it for those recursive helper functions, and we need to get back up here to the main function. Boom. So for the main function, we are going to say while exclamation point q dot is empty, we're going to open up the brackets, which in this exclamation point means while q is not empty. That's why we put the exclamation point right there. First thing we're going to do, we're going to take the next string from the q. So we're going to say let str equal q dot remove first, and put the parentheses after first. Boom. Then we're going to come underneath that, and we're going to update the result if we found a lexicographically smaller string by coming underneath that and say res. We're going to set res equal to min, open up the parentheses, res comma str. So this is just going to return the minimum between res and str. Then we're going to come underneath that, and we're going to generate a new string by adding a to all of the digits at odd indices by saying let added equal add, which is that helper function we just created, open up the parentheses, str comma a. Boom. Then we're going to come underneath that, and we are going to say if this new string hasn't been seen before, we're going to enqueue it by saying if exclamation point visited, which means it hasn't been visited, dot contains, open up the parentheses, added. Then we're going to come outside those parentheses, open up some brackets, and we're going to say q dot append, open up the parentheses, pass in added. Come underneath that, we're going to say visited dot insert, open up parentheses, and pass in added. Boom. Then we're going to come underneath that, and we are going to generate a new string by rotating the string to the right by b positions. So we're going to say let rotated equal rotate, open up the parentheses, passing str, comma b. Boom. Then we're going to come underneath that. And if this new string hasn't been seen before, we're going to enqueue it by saying if exclamation point visited, which means it hasn't been seen before. Once again, visited, boom, dot contains, open up the parentheses, passing rotated. Then we are going to come right here, open up the brackets, and we're going to say q dot append, open up the parentheses, passing rotated, come underneath that, and we are going to say visited dot insert, open up the parentheses, and passing rotated. Then after all of that, we still need to return the lexicographically smallest string that we have found by coming all the way down here, and we are just going to say return res, y'all, and that should be all she wrote. Let's go ahead and give it a run. Make sure it runs properly before we submit it. Let's see. Okay, we can't find visited, so we got a typo. Let's just put that I and run it again. Let's see. Okay, did the same thing down here. Put that I. Let's run it again. Let's see. It's accepted. So let's go ahead and submit it. Make sure it's still accepted after it's submitted. Let's see. And there it is, y'all. 519 milliseconds beats 100% of users. Not too bad, y'all. Not too bad at all. So with that being said, get one more look at the code. This is the top part. This is the bottom part, or this is the middle part, I should say. And this is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.